Good morning, everyone. This is the first lesson for Module 5. So one of the things that I told you before is that Module 5 and 4 and 5 used to be just one big module, and it was too overwhelming for the students, so I split it up into two, Module 4 and then Module 5. That means that the topics that you guys already know from Module 4 will carry over to what we're going to do now, okay? So one of the things that I like to review, and I'm going to rewrite some of the properties of the logs so that we know, okay, we already know this. And this time we're going to be solving logarithmic equations, okay? And we're going to be using these a lot. So this is the first one. This is something that you guys already know. And this is the difference. And we're going to be using this throughout. So I'm going to leave this here. And from time to time, I'm going to go back to look at these, okay? Notice that I'm not writing the base, but the base has to be a common base. In this case, if you don't see the base, then it's understood that the base is 10, but I can just write any base that I want, okay? 4. This one, log of a base a is equals to 1, and the same thing goes for ln of e is also equals to 1, and the reason for that is because we have also the base is e, even though you're not going to see the base e when you're doing logs. I mean, when you're doing ln, that's the natural log, but please understand that it's already there, okay? So this is why you get 1 when you do ln of e, okay? And again, this is something that you can try in your calculators. You have the ln button and also the log button, and your calculators, you can do that. So we're gonna do this, and now we're gonna move on to the next thing, and now we're going to actually solve an equation, okay? So this is the first one, solve this equation. Here it is, 4 ln of 5x equals to 8, okay? Now, one thing that I should have done on the previous one is also to remind everyone that log of x base a equals to y is the same thing as writing a to the y equals to x, okay? This is the exponential form, and this is the logarithmic form. They're exactly the same, it's just different forms, okay? So the reason why I write number 5 is because I'm going to use it here. I'm going to use it to solve this equation, okay? Now notice the 4 is multiplying ln of 5x. So what I'm going to do is I'm going to try to isolate ln of 5x by itself. That's what isolate means, to write it by itself. So that means that the 4, I can divide this by 4 both sides. And so what do I have now? I have now is ln of 5x equals to 2. That will be the first step. Then the second step is to know that the base of ln is e. And then what we're going to do is we're going to do exactly the same thing that we do on number 5, and that is to change it to exponential form. That will be the easiest way to solve this. So this will be written as e, which is the base, 2 is the exponent, equals to 5x. Okay. Remember, e is not a variable. E is a constant, just like pi is. Remember when you were learning pi for the first time, pi is a number. And yes, we use the symbol pi to represent the number. But pi and e are not variables, they're constants. And so what do you do now? So remember, we're solving for x. So we're going to divide this by 5. And so your x is going to be equals to e squared equals to 5. You could put this into Alex just the way it is. That will be the exact answer. Okay? This will be the exact answer. Okay? So there you have it. This is how you solve this type of equations. Okay? And we're gonna be doing a bunch of them, which means that you're going to have to recognize quickly, and this is going to come with practice, what type of equation is it and how do I do it. But the bread and butter of all of this are these properties that by now you should know how to use. Okay. Now, if you were to use your calculator and to evaluate this, you will get an irrational number. Okay, so let me do it here to tell you more or less what this is. I don't know what that number is. I'm gonna do it myself. This will be where's e? Okay, so e squared, and then divided by 2. Okay, so this gives you 3.6945, whatever. But again, this if Alice asks you to approximate it to nearest 100, then the answer will be 3.69. Okay, but again, that in that case it will be an approximation and it will not be an exact answer. What they mean by an exact answer is exactly this, just like that. Okay. All right. Let's move on to the next example. Let's see what that is. Okay. So now we're going to solve something that looks similar so that you get more practice. Okay. So this will be log of x, 5x minus 8. That's the argument. The base in this example is 2. And now you have equals to 1. Okay. So what's the difference between this example and the previous example? Well, the difference is that here they're using a len, which means the base is e. And also we have a 4 in front of it. Here we don't. Here we have log where the base is 2. And we don't have a number in front of it, so we don't have to divide by that number, okay? So we're gonna go quickly to write it in exponential form. So this will be 2, the base, the exponent is 1, equals to the argument, 5x minus 8, okay? And look what you have. You have a basic linear equation. So I'm gonna move the a negative 8 over, so I'm gonna add it here. So that becomes 10. Divide by 5. Sorry, I say divide by 5 and yet I write 2. Great, because I'm already thinking of the answer. I'm sorry about that. And this gives you 2. Okay, now in this cases, guys, one thing that you have to get accustomed to is finding the domain. This is something that you learn in module 4. So what is the domain of the something like this? Okay, so the domain is we want to make sure that the argument, which is 5x minus 8, must be greater than 0. So if you solve for x, you will see that the domain must be greater than 8 over 5. Okay, so 8 over 5 is 1.6. Okay, now let's not get confused here. This is what the domain should be. The domain should be values of x's that are greater than 8 over 5 to infinity. Why am I saying that? Because notice what your answer is, 2. Your answer is 2. The domain is 8 over 5 comma to infinity. this means that this answer is inside your domain. Why am I saying this? There might be cases, and we're going to see examples of those, in which you get one or two answers, right? And it happens that that answer is not in your domain. And when that happens, we say that the problem has no solution. Okay? So keep that in mind. So in this case, this 2 is within my domain. Okay? So here is 8 over 5, which is 1.6, and 2 is somewhere here. Okay, so that is perfect. All right, let's move on. And you can check too, you can plug in this 2 into the original equation, and you will see that you will get 1. So let me do that so you can see how this is done. So I'm going to replace the 2. I'm going to replace the x with 2. So 5 times 2 is 10. 10 minus 8 is 2. So basically what I have is log of 2 base 2, which is equals to 1. Okay, so that works too. All right, let's move on to another example. Okay. All right, so let's do this one here. This one, we're going to have 2 logs. We're going to have log of x plus 8, x plus 8 equals to 1 plus log of x plus 5. And the base here is 4. So this is the first example in which you have 2 logs. One is on the left-hand side and the other one is on the right. Okay, so this is how we're going to approach this. Our goal is to have them on the same side. We're going to have something like this, you see? Because if we do, then we know that we can write it in a single log. That's why we learn these properties. So the first move I'm going to make is that I'm going to write all the logs on one side. Minus log of x plus 5. Okay, base 4. What's left on the right hand side is the single, just one. Notice one thing, that the sign of the argument does not change sign when you move them around. Only this became negative. Okay, all right. So what do we do next? Then I'm going to write these 2 logs into a single log using, once again, this property. Okay, so let's do that and let's see how that's going to look. This is going to look as a single log. I'm going to have a big bracket. I'm going to put x plus 8 over x plus 5 bracket or parenthesis, it doesn't have to be bracket, equals to 1, base 4. You see? Notice that we somehow we go back to the basics. Notice that we started with examples where you only have 1 log, you already have a 1 in there, and you know what to do. This time, it's a little bit more complicated. The only complication is that you have an extra log, and you want to put them on one single side, on the same side, so that you can apply the properties. If this had been a plus, then it would have been a product. We'll do one of those, okay? I'm not going to get ahead, but if it's a plus, it would have been a different ballgame. So what do we do now? Okay, so now we're going to change it back to exponential form. So this will be 4, the base is 4, the exponent is 1, equals to the argument. Now this argument is a little bit messy, but it's okay. So now we're dealing with a simple rational equation. No more logs, it's gone. That's the advantage of switching back and forth when needed. So I'm going to cross multiply this thing. So this is going to get a little bit messy. I may need extra space, but let's see if I can squeeze it in. So I'm going to multiply this here and this here. So let's do 4. 4 times x plus 5 equals to 1 times x plus 8. So that's what I have now. Okay. And let's see, I'm going to have to move to the next frame. I don't have the space. Maybe I do. This will be 4x plus 20 equals to x plus 8. And then I'm going to move this x to the other side. That becomes minus x, so it will be 4x minus x will be 3x equals to this 20 on the left hand side. I'm going to move it over to the right, so it becomes 8 minus 20, which will be negative 12, and then you divide by 3 and you get negative 4. Okay, so let's see what we have here. Let's see, which one is this? Okay, so we have this negative 4. Okay, so the question is this my answer? Is this my answer? Okay, we don't know yet. So you cannot claim victory at this point because we don't know. Okay, if it was negative 4, we can check it here. Let's do that. I'm going to replace x with negative 4. So let's do this. Negative 4 plus 8 is 4. So I'm going to have 4. I'm going to have, let's do this in a different color. I'm going to have log of 4 over 4. I'm replacing it here now. Negative 4 plus 5 is 1. Don't forget that the base is 4. And the question is this equals to 1? So what do you have? You have log of 4 base 4, which is equals to 1. So this is the answer after I checked it. Now, where did this come from? This idea that log of 4 base 4 is 1. Let me show you where it comes from. It comes from here. You see this? Log of a base a is 1. Okay? All right. So that was a little bit messy, but there you have it. And the nice thing about the recording is that you can watch this again and you can figure this out. Okay? All right. Now let's do different ones, a little bit different. Okay? Let's start with something simple. 32 equals to 16, and the exponent is x plus 4. Okay. All right. How do we do this? This is different. It looks different. The exponent here is what the variable is. How do we do this? Okay. So I'm going to show you a new property that is going to make it work. Okay. But I'll show it to you when we get there. I'm going to write it here. So the argument is this, that if you have an equation where the bases are the same, it only makes sense that the exponents must be the same. Okay. Well, right now we have 32 on one side and then we have 16 on the other. But the question is there a way that we can write 32 and 16 with the same base? Okay. And the answer is yes. The base will be 2. This will be 2 to the 4th and 2 to the 5th. Okay. This is something that you're going to learn a lot this semester, learning how to write numbers with the same base when possible. That doesn't mean that two numbers will always have the same base. That's not the case. Okay, it just happened that this 32 and 16 do have the same base, which is 2. So I'm going to write it this way now. Okay, so I'm going to write 2 to the 5th here equals to 2 to the 4th. But don't forget that this thing has an exponent like that. Okay. Alrighty. So what do we do next? So what we do next is that we're going to multiply this exponent here. So now I'm going to have 2 to the 5th equals to 2. That's the base, the new base, new common base. And then I have 4x plus 16. Okay. 4 times 4 is 16. 4 times x is 4x. So look what we have now. We have an equation in which the bases are the same. This implies, by common sense, that the exponents must be the same. Okay? And look where you end up. You end up with a basic linear equation. Okay? So I'm going to move the 16 over. So that's going to be negative 11. Okay? Negative 11. And then we're going to divide this by 4. Okay? So I end up with negative 11 here. I'm going to write it so that you see where it's coming from. So this is negative 11 equals to 4x divided by 4. And your answer then will be negative 11 over 4. And there's no need to check on these, okay? There's no need to check on those. So again, this is one of those examples where you are able, because of the numbers, to write both of them with the same base, okay? There it is. All right, let's do another one. Let's do another one. Let's do one where you cannot write them with the same base. Okay, here it is. You cannot write them with the same base. E is a number, 15 is a number, but they have nothing in common besides the fact that they're both numbers. Okay, so how do we do that now? Okay, so now we have to employ a different approach. Okay, we have to apply a different approach, and this is new. So we're going to apply ln to both sides, and I'm going to tell you why both sides. And the reason why we're going to apply ln to both sides and not log, in some cases in which you could apply logs and it will be the same. You could apply log in here again, it doesn't matter, okay, as long as you do it to both sides. But the reason why I want to apply logs to both sides, I'm going to show you why. I'm going to go back to the very beginning and I'm going to tell you why. You see? Look what you have here. You have ln and you have an argument with an exponent. Beautiful. Notice what happened to that exponent. That exponent can be moved to the front. Okay? That is the reason why I'm going to apply logs or ln to both sides. And the reason why I chose ln is because I already have an e. So I'm going to take advantage of that. Okay? That's going to make the computation for me a lot easier. I don't have to use a calculator. Okay? So the reason why, again, I'm applying ln or log, in this case ln because the base is e, is because I want to move the exponent to the front. That's why. So let me go back. Here I am. So here I go. I'm going to have ln of e to the 4th power equals to ln of 15. There. What you do to one side, you have to do to the other. So it's still equal. It's still equal. But now I have gained access to something new. I have gained access to a property that allows me to move the exponent to the front. So here it is, your exponent. There. You see how nice that worked out? And there you have it. Where is ln of e? 1. See, now you're going to appreciate ln of e. ln of e is a beautiful thing. So what do we have now? We have 4x times 1 equals to ln of 15. Okay. And what am I solving for? Well, 4 of x times 1 is 4 of x equals to ln of 15. Well, what do? We divide by 4. So x is equals to ln of 15 divided by 4. What's ln of 15? I don't know. I know it's a number, and I have a calculator that I had since I was in high school. And I still use it, and I hope to inherit that to my son. And you just compute it. Now, if Alex says provide the exact answer, then this is the exact answer. Just leave it like that. Log of 15, don't forget to write log of 15, close the parentheses, because if you don't close the parentheses and you press the division sign, what's going to happen is the calculator is going to do log ln of 15 divided by 4, and that's not what you want. You want ln of 15, close the parentheses, divided by 4. If Alex says to approximate the answer to the nearest 100 or 1000 or whatever it is. But if they want you to enter the exact answer, just leave it like that. That would be the exact beautiful answer that you need. Okay. Again, this is one of the for the first time ever that we have to apply ln to both sides, and we do that for a reason. Okay. Now the question is, could you have done the same trick here on this previous example? And the answer is yes, you could have done it, and we should have gotten the same answer. But in this case, we didn't have to, because we had numbers in which we were able to write them with the same base. So you don't have to. Here, we had to. There's no choice. Okay? So little by little, you will learn and you will see. Takes practice. But again, we're doing something new. I agree. But you're using stuff that you already know. And traditionally, historically, all of my students do a lot better in test 4 and 5. And for many reasons. They're already mature. They know how to, move things around and solve for X and things like that. At the beginning, when you were doing module 1, many of you were rusty. Okay? So that is why. So I'm going to do an example now where the bases are not the same. And we're going to have variables on both sides. You see? This is more complicated. 5 is the base on the left and 13 is the base on the right, and they have nothing in common. Okay? And neither of them is E. So we're going to use ln. Or you can use ln or log. It doesn't matter. I don't want you to get confused with that. Okay? Let me show you why I use ln here. Why? Because of this beautiful thing. Beautiful. You see? This gave me 1. That's what I want. In this case, I don't have that, so I'm going to use log. Okay. All right. So I'm going to apply logs to both sides. Log of 13, and the exponent is this. When you get to calculus, you're going to work with ln most of the time, okay? Because the derivatives and everything else, the integrals are in favor of ln. All right, so this is what we did. That would be the first step. The second step is to move the exponent to the front. Keep writing ln. What is wrong with me? This is what happens when you get old. Too many mistakes. All right, I'm going to move this exponent to the front. Make sure you use a parentheses. There. Okay. There you have it, guys. This is a mess. I'm not going to deny this. This is a mess. Okay. Let's talk about this here. This here is a single term. In fact, I wrote that too far apart. That's one term. Okay. Then here, log of 13 is a number. And what am I looking for? I'm solving for x. So now I have no choice that I need to distribute this here. Okay. And why am I doing that? Because eventually what I want to do is I want to group all the terms that contain an x so that I can solve for x. That's the only choice. Okay. So bear with me here. Negative x log of 13. Just carry log of 13. We know it's a number, not a variable. Log of 13 is a number. So plus 8 log of 13. And here I have negative x log of 5. Okay. All right. This is going to get messy here, guys. Okay. So what I'm going to do is I'm going to take a picture of this and then we're going to move on to the next frame. Okay. Give me 1 second. I have to get my phone. Okay. So now we're going to rewrite exactly the same thing on the other side because I need room. Okay. All right. So what is it? I have negative 9x log of 5. I'm just rewriting it. Okay. Equals to negative x log of 13 plus 8 log of 13. There. So this term and this term contain the x. So I'm going to group them on one side. So I'm going to write this one first to the left hand side. This will become a positive. And then I just rewrite this one here. Equals to the only term, this one, that doesn't contain x. Just like when you were solving linear equations where you're supposed to put the constant on the right hand side. I'm doing exactly the same. It's just that these numbers, they're not your usual numbers. Okay. All right. So now I'm looking here at these terms, this one and this one. What is the common factor? The common factor is x. So I'm going to factor the x. There it is. So what I have left, I have log of 13 minus 9 log of 5 equals to this thing, 8 log of 13. There. And then to solve for x, we're just going to divide all of it by this. So this is going to be messy. Log of 13 minus 9 log of 5. And that's what x is. Okay. And in this cases, so this is what x is, okay? There. This number. In some cases, this is what Alex wants you to do. This is what they call the exact answer. And you enter it like that, okay? So again, I'm not saying that this is easy. This is going to take some practice. Most likely will take a whole page just to do one. But that's what it takes, guys. That's what it takes. It takes a lot of work, okay? So let me go back to the beginning. Notice where we started. We started with this animal there. And what made it more difficult was the fact that we had variables on both sides. And that made it difficult right here, right there. And now you have x's here, x's there. Okay, so that is why it turned out to be more work than anything else. But this is algebra. Algebra is finding the unknowns, okay? Solving for x and so on. Let's do another one. Okay. Let's do, let's do this one. I'm looking at this one here. Log. No, well, this is something that we did. Let's look at something like this. Hold on, let me erase this. Let's see here. 5, 13, 16. Okay, so let's do another one that is similar so that you get accustomed to this, so that you're not afraid of these things. Whatever, I don't want to number them because I lost track of how many I've done. We've done 16. The exponent is this. Here's 15. And the exponent is negative 9x. Okay, so there you have it. Same thing. So let's go through the motions. Okay, let's go through the motions and then we'll see what we get. So this most likely I'm gonna use 2 frames. But don't panic, guys. Don't panic. Okay, so what do we do first? We apply logs to both sides. Here it is. Log of 16. And this is negative x minus 2. These things are messy, I'm not gonna lie. Make sure that you keep track of things. Okay. There it is. Now I have access. I have a gain access. The fact that I have logs on both sides, I have a gain access to move the exponents to the front. Don't move the exponents to the front without doing this step first, which is to apply logs to both sides. Don't do that. Otherwise, you're breaking every rule there is. You see? There it is. There you have it. So now I'm going to move this to the front. There. I'm going to multiply, not to the front. I'm going to distribute that. That's the correct term. I'm going to distribute log of 16, which is a number. And I'm going to end up with negative x log of 16 minus 2 log of 16 equals to negative 9x log of 15. This guy is just one term, and it contains an x. What am I going to do? What I'm going to do is I'm going to move it to the right because I want to have all the terms that have an x in them on one side. So I'm going to move this. This becomes positive. Minus x log of 16. And guys, this term, negative 2 log of 16, doesn't contain an x. It's a constant, therefore I'm going to move it to the right side. Don't forget to change the signs, okay? There. So now I'm going to take this to the other frame so that we can solve for x. Okay, so there it is. Okay, here's the other frame. I'm going to write it again. 9x log of 15 minus x log of 16 equals to 2 log of 16. All right, so now, same thing as we did on the previous one. All the terms with x in them have been placed on the same side. So I'm going to factor out the x. Here it is. X. What do I have inside the parentheses? 9 log of 15 minus log of 16 equals to 2 log of 16. All right. One more step and we're done. We're just going to divide by this. And we do that on both sides. A lot of writing. Minus log of 16. There. So this is what x is. This number here. That will be the exact answer. Let me write it nicely. X is equals to 2 log of 16 over 9 log of 15 minus log of 16. Okay, this is what the answer would be. This will be, again, what Alex will call provide the exact answer. Okay, so this will be the end of this recording. This is the first lesson on module 5, and then we'll do the next one. Okay, so guys, take care of yourselves, and I wish you the best. Okay, all right.